What is the very first statement always? The given. Okay, so let's set up our proof. We're going to have to draw our two columns. Maybe. I'll come over here. The left side is my statements. Hold on. I think I need to change the battery in my pen. All right. So the left side again we're calling it statements. And the right side is reasons. And we're going to give our first statement, and our first reason is always what is given to us. Always the given stuff. We should not miss that first statement and that first reason. Jakari. There we go. So this is where we have to think about where can we go from here, okay? What I'm given is that I have two congruent segments. Like yesterday, we were told we had two congruent segments, but we were also given the length of those segments. Are we given the lengths of those segments today in our picture? So we're not given any other information besides that picture and besides the fact that QT is congruent to RV. And we're trying to prove that the two small pieces, QR and TV, are congruent. So if I give you two congruent segments, the only other thing you could say is that they were equal to each other. However, I don't have any values to say that they're equal, so I don't even need to do that. Well, technically we do. We do. Because I forgot what we have to do. So if I have two congruent segments, the only thing that we can say is that the lengths of those segments are equal. So for my second step, based off of my first step, I'm going to say the same thing, but instead of saying segment QT is congruent to segment RV, I'm going to say segment QT is equal to RV, because now saying that, I can talk about the lengths of those segments. And what definition we mentioned yesterday says that if they're congruent, then I can say that they're equal. It's a definition of to say that they're congruent and then they're equal. Definition of what was one of the definitions we talked about in our notes yesterday? Definition of close. Look back at your notes yesterday. One of the definitions, it says if I tell you two things are congruent, then I can say that they're equal because of the definition of congruence. Okay. So the definition, and again, I'm going to abbreviate here, just because we are going to do a lot of writing. So anytime I see the word congruence, I'm putting a symbol. Do we know anything else? Are we given any other pieces of information? So let me ask you this. If I don't have any other given information, this is how it works with proofs. If you've exhausted all of your given information, what you have to do next is go to your picture. Okay. I know that segment QT, the length of it, is equal to segment RV, but let me ask you this. What else do we know about segment QT? Looking at your picture. I'm focused on segment QT. Just from my picture, what else could I say using one of those postulates that we talked about yesterday? Thinking about some of the things that we've talked about. if I'm talking about segment QT, I know that it is equal to RV based on what they told me. But looking at my picture, what else could I say QT was equal to? Well, it is equal to RV, but we already said that. VR and RV are the same. So yes, but what else could I say about this segment? Forget this piece. What else could I say about QT? Oh, okay, QT, TQ, same thing. That's not changing it. Didn't we talk about being able to add some segments together? What two segments add together to give me QT? RQ and RT. Okay, so what we need to say next, based off of this picture, this little segment plus this segment gives me the whole segment. So that's what we want to say. Okay. I'm just trying to think about other things that I can say about QT. Keep in mind, we're trying to get QR and TV. So at some point we have to mention QR and TV. So what I'm going to say is QR plus RT is equal to what segment? QT. And keeping in mind that we're talking about the same thing, we want to do the other segment. The other segment they told me was RV. Could I say two segments add up to be RV?
Yeah.
Which two? RT and TV. So for the same reason, we're going to say RT plus TV is going to equal RV. That came from looking at my picture. And what says that I can take two segments, add them together to equal a larger segment? It was on our notes yesterday. It's a postulate. The segment addition postulate. So that's going to be our reason. Segment. I can get my thing to right. Postulate. Okay, and you can abbreviate if you want to. Segment addition postulate. I put both of those in the same step because they have the same reason. You can split them up if you want to, but then you're just writing the same stuff twice. So far, so good. Okay. Now let's look at this. I'm going to kind of highlight a couple things. If we're looking here at this second segment, I got QT is equal to RV, correct? What else is QT equal to? Look in step 3. What else is QT equal to? QR plus RT? So don't we have a property that says we can take one thing out and replace it with something it's equal to? So I'm going to take that QR plus RT, and I'm putting it in place of QT. Going back to my second statement, bless you. What is RV? What else is RV equal to? Besides QT. Look at step 3. What is it equal to? RT plus TV. So I'm going to take out okay, so let me show you what I did because it's easier for me to show you up here. If you look at step 2, and then we look at step 3, let me try to keep it color-coded. What I did was I took this out. Nope, that's not a different color. That's going to be a different color. I took this QT out and I replaced it with what I said it was equal to. So that's how I got the QR plus RT. Does that make sense? And then I took out the RV and I replaced it with what RV was equal to. Does everybody see where that happened? What's the property when I take things out and replace them with stuff they're equal to? When I'm not here, what do you have? A sub, okay, substitute, right? So when you take something and you replace it with something that it's equal to, we call that A, or the substitution property. I'm running out of room up here too. I'm gonna have to finish this on the board because I'm running out of room up there. Okay, so here we are. This is step 4. Keep in mind that we are trying to get to the fact that QR is congruent to TV. But what I want you to look at this statement. Do you notice anything that might be the same on both sides? RT. Okay. Just like if I were solving an equation and I had 3x plus 2 equals 5, you would subtract the 2 over, right? If I wanted to get rid of this RT over here, since it's the same, does it make sense that I can do this? I can take the same thing away from both sides. Okay. And if I did that, what would be left? What's left over here? QR is going to be equal to what? TV. And what did I just do to get rid of that? Subtraction property, okay? So my next step, I'm going to try to squeeze it in. I might just write over. My next step is going to be that QR equals TV because of the subtraction property. I should have made this bigger so I have more on the right. Does that look exactly like what I'm trying to prove, or is it close? It's close. So if I know that QR is equal to TV, is it okay for me to say that QR is congruent to TV? Because of what definition? It's on your notes. We've already used it as a reason here. Okay. So the reason here would be the definition of congruence. For definition of congruence, you can go from congruent to equal or equal to congruent. But the goal is you have to say exactly what they're trying to prove. Okay, this is kind of like the algebraic stuff, except for now we're just talking about objects. But I was able to say that 2 parts made up QT, 2 parts made up RV. So then I was able to say that those 2 parts were equal to each other because QT and RV are equal. Then I was able to subtract the same piece off of each side. And then I was able to go and say that they were congruent after that. Okay? Does that make a little bit of sense? Now, would I expect you to do one of those from the get-go all by yourself? Absolutely not. These take some time to get used to the idea of what we're doing. The more we do, the easier it gets. Now, I'm going to have to erase some of this because I need to see the next problem. Has everybody got it copied down? Okay. All right, so we're going to do the same thing for number 2. Try to write a little smaller this time. Let me go ahead and set up my 2 columns. And what can we already fill in? The given. Okay, so go ahead and write what you're given. It tells me that CE is congruent to FE. And it also tells me that ED is congruent to EG. I'm not making this up. I am getting it right here from that given information. And I'm going to draw my picture up here so I can label it and point to it. Now, what I also would recommend, when you're given some congruent stuff in your pictures, I would recommend that you mark that in your picture. It helps you see what you're dealing with. So let's mark what they told me. What's the first pair of segments they told me were congruent? CE and, what's this at? FE. Okay, so those 2 are congruent. And then it told me that segment ED is congruent to segment EG. And look at what we're trying to prove. What are we trying to prove? What does it say? Prove says what? Segment.
Is this the
Yes. That's why I'm saying everybody needs to be paying attention. What does it tell me I'm trying to prove? Segment CD is congruent to segment FG next Wednesday. So far, so good. Okay. Now, just like the last question, if I'm given congruent segments, what is the only thing I'm able to say next? That those segments are not congruent but equal. So that's what we're going to say. We're going to basically repeat step one, except for we're going to lose the segment bars and we're going to lose the congruent signs and change them to equal signs. So I'm going to go segment CE is equal to segment FE. And also in the same statement, because it's the same reason, segment ED is equal to segment EG. And that is the definition of congruence. Uh-oh, I put that CE is not supposed to have a segment bar there, sorry. That one is though. Everybody ready? Okay. All right. If I know two things are equal and I don't have any values, can I go any further? Does that tell me anything else? No. Okay. So then we need to look at our picture. Again, keeping in mind what we're trying to get to. We're trying to get to the fact that CD is congruent to FG. So what I want to do is look at my picture. I've marked the congruent parts. I have nowhere else to go based off of what I'm given. So now I need to go to my picture and say, is there anything else I can say? And what I mean by that, is there anything you can tell me about CD and FG just by looking at your picture? It's very similar to what we did the last question. Okay, what can you tell me about CD? What is it made up of? CE and ED, right? Does this small segment plus that small segment equal the whole segment? So let's say that. Let's say that segment CE plus segment ED is equal to segment CD. Everybody ready? What can you tell me about FG? What two pieces make up FG? FE and EG. These are going to be the same statement because it's the same reason. So FE plus EG is going to equal FG. And what says that I can take two segments and add them together to get a bigger one? What's it called? Segment addition postulate, yes. And that's my abbreviation for segment addition postulate. Is everybody okay with that? Sure. All right, I want you to focus on trying to keep straight which one I'm doing. Okay, let's focus on this first. Looking at my next step. Let me ask you a question. What else does CE equal? Okay, if I'm looking at this statement, I want to replace this. What else does CE equal? FE. So can I take that CE out and put FE there? Okay. And then, in that same statement, if I wanted to replace ED, what else does ED equal? EG. Okay, and I'm not replacing the CD. I just replaced the highlighted portions. I replaced the CE and I replaced the ED. Is everybody okay with that? Sure, okay. And what lets me replace things? Substitution. I'm going to skip down here a little bit so I don't have to write over the words. Now let me ask you this. What else does FE plus EG equal? Look in step 3. What does FE plus EG equal? FG. So can I take that FE plus EG and replace it with FG? Mm-hmm. Yes. And again, I replaced something, so what property is that? Substitution. Now look back at what you're trying to prove. We're trying to prove that CD is congruent to FG. Is that what I have listed right now? Is CD listed first and FG listed second? In step 5, is CD listed first and FG listed second? Is there a property that says I can just switch those around? Symmetric. So that's what I'm going to do next, because I need it to be exactly in the same manner as it is in my problem. I just switched them around because I need it to look like this right here. Okay. And then again, I have to have it look exactly like my proof statement. Right now it says CD equals FG. What does my proof statement say? CD is not equal to, but congruent to. So the last step is going to be to say that CD is congruent to FG. And what reason says we can say something, if something is equal, then it's congruent? The definition of congruence. The problem is you're dealing with a bunch of letters instead of numbers, and so it gets a little confusing. But if you think about the statements that you have, okay, think about what they're giving you. Looking at your pictures, you're going to use segment addition postulate a lot. Okay, you're going to be given some information about smaller segments. You're going to need to add them to get the larger segments. Okay, do I expect you to be able to do these right now? No, we're going to do more and more and more practice on those. Is everybody okay with that? I don't think we'll finish all 4, but we are going to do the next one. So let me erase. Does everybody have this one written down? Or I only gave you 3, didn't I? Okay, good. We only got 1 more. Let me erase this. And go ahead and set up your third proof. Again, we know the very first statement and the very first reason is going to be our given information. All right, my given is R is the midpoint of QS, okay? And then it also gives me some more. It says T is the midpoint of VS, and then I get some more given information. Segment QR is congruent to segment VT. All of that is given, and so I'm going to write it all in the same step. Okay. Sometimes people split up the given information, but I don't like to do that because I tend to think sometimes we forget about those. Wait for everybody to write that, and then we'll keep going. But I do want you to take a look back at your notes yesterday. Look at the definition of midpoint. And we used this in one of our proofs yesterday. The midpoint says it divides a segment into 2 congruent segments, yes? So let's start with the first part of my given information. If R is the midpoint of QS, look at your picture. R is the midpoint of QS. What 2 segments would be congruent? QR and RS, so that's what we're going to say. we're going to say QR, segment QR, is congruent to segment QS. And then the other part of the given that tells me my midpoint, T is the midpoint of VS, so what other segments would be congruent? VT and ST or TS, however you want to say that. So segment VT is congruent to segment ST. And how do I know those segments are congruent? What did it tell me in the first step? That R and T were the midpoints. So that is going to be the definition of midpoint. So far, so good? Now, it wants me to prove that RS and VS, no. Hold on, there's a typo. I've got to figure out where it is. QR and VT are congruent. I think this is supposed to say that our QS is congruent. That is a typo. I should have caught that before. RS and TS. That's what it is. Sorry. On your proof, scratch that out. This is supposed to be TS. I knew something was wrong. Right, right there on your given statement, change the VS to TS. Oh. Sorry, I'm having a pain. All right, are we good? Now, if we say things are congruent, what do we say next? We say that they are equal. So we're going to do the same step, but we're going to change it from congruence to equal for both of them. And that is the definition of congruence. Why do we need to change it to equality? Because you cannot substitute, you cannot replace one thing with another unless it's equality. You can't do it for congruence. Yes, ma'am. Mm-hmm. It's up to you. Okay. All right. What other information do they give us? What two segments are congruent? I just highlighted it. QR and VT. All right. So look at this piece here. Well, not that piece because we can't replace. Let's look at this one. We know that, what am I trying to get to RS? Y'all, I jacked this one all up. Go back to step 2. QR is not congruent to QS. QR is congruent to RS. My bad. Change those two. I made a mistake. That is my fault. I need to change that to RS. I put the wrong letters on there. That's why I wrote it. Yeah. All right, so now that we fixed my mistake, and I'm sorry about that, I was not paying attention to what I was doing. All right, QR and VT are congruent. What else is QR congruent to? What is RS? So can I, this statement right here, can I say that instead of QR, can I put VT? No. Where am I trying to go? RS, okay. QR is equal to RS, yes? I need to add one more statement. My bad, y'all. I'm jacking this one all up. Take this piece right here and change it to QR equals VT as well. I need to add that step in there for the same reason. I don't like this one. I won't give you one like this on a test, I promise. This one's got too much to remember. All right, so if QR equals VT, what else does QR equal? You told me. Is highlighted in green. QR equals RS, okay? And then what else does VT equal? I highlight it in blue. ST, okay? That is going to be substitution. Now, isn't ST the same as TS? Yeah, okay. So if I know that they are equal, what can I say next? They are, which is what it wants me to say. Okay, and I just changed it to TS, so it looks just like what they have. You could keep it as ST if you wanted. Again, I'm not going to give you one like this. Mine are going to be a little bit more straightforward. And this is going to be the definition of congruence. And I'm sorry for messing that one all up.